Oh, bananas
Okay.
to you, Dave.
Yeah. Well, we all know bananas are important. So this is the July 6th, 2021 session of TangerineSDR and HamSci technical session. My name is Dave, KV0S, and this week our rain stopped finally for a little bit, and I've been doing some antenna work, getting things cleaned up and fixed. So that, and I did have to sponge up some water out of the ham shack a little bit, but that's about it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Things are going fine here in Scranton. I've been continuing to advise students on a variety of research projects that involve everything from trying to figure out which way the grape observations are going, to doing modeling with ray tracing, to looking at super darn data. And I've personally have been working on writing a paper for the Society of Amateur Radio Astronomers Conference that's coming up. And that paper is basically how the Tangerine SDR can be used for radio astronomy purposes. And I've been working with the Radio Jove people. Dave Typinski has given me a lot of information. And then I've been iterating with Scotty and Tom McDermott and John Ackerman on Dave's list, and we've been going back and forth. So the paper is getting close to being done. I have essentially one more big section I have to write and kind of clean it up. But I think that last section is really the astronomy considerations for the Tangerine SDR. So I'm going to try really hard to get that done this week in between all my meetings with students and everything else. So W2NAF, back to net.
Well, fine business. And
Could we
next
get
up,
people to mute? We're getting some feed through.
I can just mute everybody and then they can unmute themselves as they need to.
Great, thank you.
okay. Next on the list, we have Bill, WB4EJ. Go ahead, Bill.
AB4EJ here.
Sorry.
Yeah, good evening, Dave, and good evening to the net. Yeah, it's been a difficult week. It occurred to me that I need to put together a unit test package for letting the local host software test itself, because as you know, as you add complexity each time you do that, you need to test everything, and it's hard to do that effectively by hand. So, man, there are so many different test packages for use with Flask, and most of them assume that you're running a public-facing website that involves databases and ties in SQL alchemy and uses blueprints and all this and that, and really was not suitable for use with our relatively simple user interface for the local host. So finally, what I ended up with is a thing called using PyTest Flask, which I'm just getting started with. I'm going to try and get as much coverage as I can for the unit testing of the user interface for the local host. And I think in order to do complete testing, I think my test package will have to start up a local copy of the data engine simulator and verify that the thing responds, because it really doesn't work unless it talks correctly to the data engine. And so anyway, let's see what else. I'm a student working over the summer, and we're going to try and unify the work that was done last academic year so that all appears in one container within Django on the server. Hopefully we go out there and look at the server and it hasn't been blown away by hacking companies. Anyway, so we're making progress slowly but surely. I really wasted a lot of time this week because I had to try 5 different test packages before I found one that would work, but I got it working now. So anyway, progress. Back to net.
Okay. Next on the list, we have Dan N4XWE. Go ahead, Dan.
No, we can't hear you. It's very distorted, Dan.
Is Dan saying anything?
Yeah, I could hear kind of a scratchety sound there, but he's not coming through.
No, he's not. Nope.
He said, go ahead, Dave, with someone else.
Okay, so let's go ahead, and next on the list is Dave Witten, KD0EAG. Go ahead, Dave.
Yes. Hello. I've been doing this and that, working on what have I been working on? Oh, on I made the logs that are uploaded to the Linode server visible. It's a pretty rudimentary, but if it's at least people could theoretically download individual logs for a given period, a given day, and compare them or something. I'm working on other things, securing both. Well, I've pretty much secured that, but I'm working on configurations for the local, for the pies that to let them display a real-time output from the magnetometer and other things like that. Some configuration information maybe, but nothing hugely exciting. Just kind of drudgery. So that's all from me.
Fine business. And next on the list, we have David, N1HAC. Go ahead, David.
Good evening, everyone. I've been working on building out our existing receivers. And one interesting update is Phil Erickson, our host in Schenectady, has installed a new GPS unit that should be able to give TEC data. And it's a prototype of a, I believe, lower cost and maybe similar to what we're hoping to deploy with Tangerine. Other than that, we've had a lot of storms, 2 inches of rain, and a good thunderstorm that took down a tree that took down 2 of my antennas. And so I've been trying to piece them back together. Back to net.
Well, too bad about that, but good news on the TEC. Next on the list, we have another David, KE8QEP. Go ahead.
Hello, everyone. I guess I don't have much to report. I'm mostly here to listen. On the Tangerine listserv, I think people may have seen, Dave helped me get my magnetometer logs upload to his site. But my y-axis on the magnetometer seems to have gone a little cattywampus after I was messing around with some grounds. So there's some images of that in an email I sent there. If anyone has any ideas as to what might be going on, it happened right after, I think something was disconnected and things were shut down and turned back on, and I was poking around in places I probably shouldn't have with a multimeter. So maybe I fried it. The y-axis is still responding to major changes, so it's not totally dead. It just has this sort of square wave imprint on it. So if anyone has a chance to take a look at that, I'd be interested to hear what they have to say. Back to Net.
Yeah, I noticed that you had those square waves even on your temp sensors, and that was a kind of an interesting thing. So, one's remote temp, which is out in the ground, and that one for your site was around 19 C, and the one in your house was 30, and then it jumped 10 degrees C, and then went back down.
Well, some of the jumping was when, well, if I turn off the magnetometer altogether, it cools down in the pipe, and then you turn it back on, and you can see it reaching equilibrium again. But then I also put the Pi in a metal case, and I've had that open and closed, and so that I think that explains those. With my tests with the cars, I mean, there were square waves because I was moving cars around, but then something else happened, and there's some kind of extra signal, and it's only one axis, so I can't. I'm assuming it's not a general noise issue, otherwise it would affect all three. So maybe I did something to the chip. I don't know. I'm just a geologist or a biologist, depending on the day. So I don't know.
Well, I'm a forester, so I do the same kind of thing. But I did cut my cable this week with a lawnmower, and it continued to feed numbers, but they didn't change the whole week or the whole day while it was out. I got a 1-day delivery of a new cable, so it's back and running again. But anyway, I'll go on. Next on the list, we have Dev, KC3 PVE. Go ahead, Dev.
Don't forget to unmute.
Sorry. Good evening, everyone. So I took the July 4 as break, and from tomorrow, there will be officially start of the work days. I did few things that I had that were pending, and I think I'm back to catching up to my work. And next week, maybe I'll make some progress. So this week I don't have much progress to report. Thank you.
Well, fine business. And let me go through this. We have Kong jumped in there. Do you have any comments, Kong?
Well, the last week I've been working on I had two scripts, one for the CIC filter and the other one for the FIR filter. But they are in no way final because I'm still pretty confused on some of the parameters that we use for these filters. That's pretty much what I did the last week.
And next on the list, let's see, would be Elizabeth. Go ahead, Elizabeth.
Hi everyone. Took the day off today from work so that I'm able to attend the meeting today. My team and we've been working on finishing up building a VLF board that we're planning to fly on a helium balloon next month. We have an SDR as well, but we're not planning to fly the SDR because we don't know what can we collect with the SDR, what kind of data we can actually get if we fly it. So that's what we've been working on, finishing up building our VLF payload. And also got my abstract got accepted at AGU to host a session in December. So the two other members of my team and we're going to be hosting a AGU session to, let me see if I can send the name of the session here. It's actually, let me see. undergraduate student-led STEM research, promoting scientific research collaborations between students, scientists, and engineers. That's the name of the session. So if anyone wants to submit any abstracts, you're welcome to.
Well, fine business. And next on the list is James. Whoop, he just jumped. KG4DSG. Go ahead, James.
Good evening, Dave and the group. I'm just listening in this evening and trying to get some work done for tomorrow. So back to the net.
Okay, next on the list, we have Jay, KB8SBI. Go ahead, Jay.
Okay, hi there. Nothing specific for the ham site tonight, but a couple interests of going on in the amateur community. I just read on the league website that the FCC has fined a company that sells drones $3 million for importing and selling things that are not legal, drones that are not legal to be used in the amateur radio bands, but they are being used. You can go to the league website and we read the details. However, that brought back something personal for me. Is I was a member of the American National Standards Institute Committee, ANSI, that wrote the latest ANSI document for cybersecurity and drones, and saw to it that amateur radio, the amateur radio sections in there were correctly worded and favorable to amateur radio. And I coordinated that with league headquarters with Kermit Carlson, Whiskey Niner X-Ray Alpha, who chairs he's the Central Division Director. So he and I worked closely to make sure that that wording was correct in the ANSI standard. So if you want more information on that, go to the league website. The other thing is that a storm rolled through here and broke my HF antenna. And they don't call it morphine junk antennas for nothing. There's a counterpoise for 10, 50, and 20 that's like this, and it sticks out from the main antenna, so it's mounted to the main antenna, and there's an L bracket that holds it. Well, that L bracket is cheap, very cheap aluminum, and it failed. So my HF antenna is not in good shape right now. Hopefully I can get a replacement part from MFJ for that. Other than that, nothing really new from Detroit. 7-3, I'll catch you later on down the log. Hope you all had a good 4th of July. Back to net control, WB8SBI.
Well, fine business. And next on the list, we have Jim, K4BSE. Go ahead, Jim.
Well, good evening, all. Got a lot to report this week. I've been celebrating with family and doing some other things that didn't have anything to do with ham radio or this project, really. I do have one question. I don't know whether anybody around on here can answer it or not, but I am running out of space. In fact, at the moment, I'm out of space on the SD card in the Raspberry Pi, monitoring the grape. And is there any reason? It looks like there are several directories that duplicate the raw data. And I'm wondering if there's any reason that raw data, and some of them also have the smooth graph in them. I'm wondering if there's any reason why those cannot be deleted so long as I have a copy of everything somewhere else. I'm putting it on a different machine, running into a lot of trouble with the 64 meg or gig, whatever it is, gig, I guess, memory of the SD card in the Raspberry Pi. And let's see, besides that, I've been continuing to take data on 10 megahertz WWV and see some difference from one day to the next. I need to sit down and spend some time going through all of the graphs, though. I had something curious happen about a week ago. All of a sudden at noon GMT one day, noon GMT the next day, I had my data flatline with a very high received signal level and nothing else, no data. So something was wrong that day, and I can't figure out what it was. I can't find anything around here that could have caused it. But it was interesting that it was from noon UTC one day to noon UTC the next day. That's all I have. If somebody else can answer my question about leaving the copies of the data on the SD card, I would appreciate it. Back to net K4BSE.
Well, fine business, and somebody can hopefully comment on it. I would basically have some sort of way of.
I'm sure I can comment on it during the open session or whatever.
Okay. So we'll go on down the list, and next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. This week, I was working more on my test box for my active VLF antenna. I got all the holes drilled and the jacks mounted, but I don't really work with a lot of aluminum enclosures like I used to. So when I was punching the area where I wanted the hole, I made the mistake of not reinforcing the other side. So when I tried to punch, it ended up bending the aluminum enclosure and cracking it in one area. But I was able to get it bent back and working. And another issue I had was some of the drill bits that I was using, the tips were dulled, and that caused the bit to travel as I was trying to drill the hole on the drill press. So some of the holes were not where I wanted them to be, but I drilled holes alongside it, and I was able to get all the jacks basically where I wanted, even though it's a fairly tight fit. But again, what this will do is this will allow me to power my active VLF antenna and listen to the audio output through a headphone amplifier to ensure that it's working. And also, when this is eventually going to be connected to the VLF module on the TangerineSDR, it also has a RCA jack and a toggle switch, and it'll output the audio output directly into the VLF module audio in. But for the time being, it's going to be connected to a Raspberry Pi sound card, and the processing is going to be done on there. I also was able to go to a local ham fest. I've been meaning to go for many years, at least since 2015, and I finally was able to go. There was a lot of cool stuff. The flea market, it's always best only to bring so much money, so you could control your spending. But there was a lot of really cool stuff there. There was examinations going on, and I was able to talk to the local club that hosted the ham fest, and I'm in the process of getting my ARRL VE accreditation. I'm already accredited with W5YI, so I'm in the process of filling out the form for ARRL, so I could help with exams for the local club and hopefully with the university. Oh, and one quick comment with the Raspberry Pi and the running out of space. What I do for my VLF SDR, the Raspberry Pi has a USB drive in there, and that's formatted ext2. That's actually better in this case for constantly writing. So it works up pretty well. So you could use an external or a USB stick, and you could transfer all your data there, and then eventually have it transferred over the network to another PC. Also, this is a trick that I learned with the being involved in the amateur seismic community, recording seismic data on Raspberry Pis. A lot of people use SanDisk industrial SD cards, and they are made to withstand much more write cycles. But their storage, they're a little bit more expensive. But the cheaper option would be to use a USB drive formatted with ext2 and then transfer it over to another network storage. That's all I have. Back to the net.
Well, fine business. And let's see. Next on the list, we have Jules, K2KGJ. Go ahead,
Okay.
Jules.
Good. Is the audio fine?
Yes,
up?
it's
Okay.
good.
Just a comment to Jonathan for hole drilling in soft aluminum without a center punch. You can try titanium nitride coated brad point drills and also split point drills, which tend not to wander. Anyway, spent some time this weekend with the family. The 4th, I did apparently manage to catch the X-class flare on the 3rd on the magnetometer. Produced a very small pip on the y-axis, or the x-axis rather. There's probably about 5 nanoteslas in amplitude. I sent the trace on to Hyman to do a verification on that, but it does look like I actually managed to see the result of that flare hitting the ionosphere. That's about it for this week. Back to net.
Well, fine business. And let's see. Next on the list is Khan. Go ahead.
Hello, all. Not much new with me. What is it? I got my car back. I think it was last week. Spent a lot of money. I was hoping to buy, like Bill, I wanted to buy a linear amplifier, but that has to wait for a little bit. Other than that, I'm still programming some graphic stuff. I'm doing Vulkan now. What is it? I was doing OpenGL. The concept works, so now I'm reprogramming things in Vulkan. So yeah, back to that.
Okay, well, fine business. And next on the list is John, KG6IPP. Go ahead, John.
I can only think of one question this time. What equipment is currently available for us to use?
Scotty or Nathaniel, I don't know if we have anything except for the beta testers.
Yeah, so far we're still kind of beta testing. So
Okay.
I think all the magnetometers have been distributed so far, the prototype magnetometers. People who want to build grapes, we do have plans for building grape ones. And so you can build one, and there are some people who will give you some help. So I can put the link in the chat for where you get the information on building a grape receiver.
Are the magnetometers critical for this project?
It depends. It's a very modular project, so I wouldn't say it's critical. I mean, everything is critical and nothing is critical all at the same time, because ideally you'd want to have as much information from as many places as possible, but that's obviously not possible.
If you want magnetic data,
also,
it's critical, right? Because that's how you get it.
What's that?
If you want magnetic data, then it's critical because that's how you get it.
That's right. So it depends what your interest is. If you're really interested in the geomagnetic field perturbations, then the magnetometer is critical. The other thing to know is that you're not going to be able to make good magnetometer measurements unless you have a rural location. So that's something to be aware of as well. But I would
150 feet from things is quite a distance.
What's
Even
that?
around here. Even around here, 150 feet is quite a distance.
Yeah, what 150 feet from what?
Anything metal, that's what I've heard in the past.
Right. And so it's hard to get that distance in your location?
Yes.
Right. So that may not be the best instrument for you to install right now. But certainly the grape receiver is a good candidate for you, because you want to be able to hear WWV fairly well to use the grape, but it's not as sensitive to say cars passing by or other things that would affect the magnetometer in a negative way.
Mm-hmm. I would, I'm still interested, but I just don't see being able to use the magnetometer here.
Yeah.
Yeah. So I think if you'd like to build something and start using something, I'd suggest trying the Grape version 1. And I just put the link in the chat to where you can get more information on that. And you don't need the magnetometer for that.
What? I can just wait until that thing is well ready to use.
Okay. There's going to be a little bit of time because they're working on the Grape version 2 right now. And that's the one that we're looking to more or less mass produce.
Mm-hmm. Okay.
Can I go ahead, Nathaniel?
Go ahead. Yes.
Next on the list is Michael, AA8K. Go ahead, Michael.
Well, thank you, and greetings to everyone listening. Jonathan, one of the tricks I use if I have to make a large hole in a critical location is to drill a pilot hole first with a very much smaller bit. And if the bit drifts, it's a small percentage of the distance. And then the larger bit will just follow that right, well, it may corkscrew depending on how small you go. Back to you, Dave.
Well, fine business. Let's try to see if Dan got his audio working. Dan,
Yeah,
are
I
you
think
there?
I did. Can you hear me now?
Yes. Yes, you are.
Yeah, what happened was for some reason Zoom decided that it wanted to use the microphone on my camera instead of the system microphone for some bizarre reason, and I didn't check it beforehand. So it was kind of my bad, but it's not a good thing in Zoom. Anyway, I did want to mention one thing. I wrote a script a couple of months ago to install Python 3.9.5 onto Ubuntu 20.04 64-bit for the Raspberry Pi. So if anybody is interested in doing that, I believe that the default version installs with 20.04 is 3.8, and 3.9.5 is, at least as of a week ago, was the latest and greatest version of Python. So if you want the latest and greatest Python, that script does it all for you. Anyway, that's about it from here. Back to you, Dave.
Okay, fine business. And next on the list, we have Scotty.
WA2DFI. Fooled you.
Yes, I say it every week and I forgot.
Sorry.
You didn't type it in there for me.
That's because we signed up for a pro account
Oh,
And so now whenever I get on Zoom, it wants to use the pro account and it doesn't put my call sign in. So
okay.
that the other one did. So I'll see if I can fix that. Anyway, last week we went over with the CAD guy the perturbations of plugging together all the modules, and we found some conflicts, mechanical conflicts between parts that were too tall on the two boards facing each other. So we basically, I made a list of all the components that were higher than half the distance between the clock module and half the distance between the RF modules. And then anything that was taller than half, we went through and looked at anything that was taller than half on the facing boards, because the secondary side of the data engine faces the secondary side of the RF modules, and the secondary side of the clock module faces the primary side of the data engine. So we found some capacitors, large ceramic caps that were interfering. So what I ended up doing is I made the change on the data engine. I changed some 47 mic capacitors to multiple 22 microfarad capacitors, which were only a millimeter thick instead of being 2.8 millimeters thick, because we have 4.14 millimeters between the clock module and the data engine. And we have 2.15 millimeters between the RF modules and the back of the data engine. So we have to be really careful when you stack caps up that are 2.8 millimeters high underneath each other, and you only got 4 millimeters, that doesn't work. So anyway, we made the changes there. So now I'm confident that we can actually build the boards and plug them all together, and there won't be any mechanical conflicts. And then also been working with Tom McDermott on some changes to the RF module because of the changes we had to make to the data engine. And he wanted to change the parameter, the level on the noise generator, and he can fill us in on what he did there. So I'm going to just make a few changes there, and we'll get those incorporated, and then we'll be ready to go, minus the two parts that I don't have on the data engine. And still working those, trying to see what we can get, but I'm not having any luck so far. So I guess that's it for this week. Back to you, Dave.
Well, fine business. And next on the list is Tom in 5EG. Go ahead, Tom.
Well, good evening, everybody. Well, it's been a pretty busy week on the project. Nathaniel sent over some good comments from Dave Topinski, and we decided to change the level of the noise generator on the receiver. And I did a little bit of math to figure out if we can handle the cases where we're trying to characterize the noise figure on the receiver, but also trying to characterize the level of the things that Dave is trying to measure. I think we can do it. So we changed the resistor values. And I still have to look at the regulators to look right, but I haven't checked pinouts and things like that. So I'll do that and look at the thermals on the regulators, assuming I can find the data sheets. Been working on the WX Python app for doing register reads and writes. Added buttons for the clock programming, where it will open up a file and that's produced by the synthesizer Clock Builder Pro software that programs the synthesizer chip. And so I'm trying to write in a reader for that file so it can program the clock module with just a couple of buttons. That still has a long ways to go, but learned some of the tricks on WX Python for the right way to structure the software, so every time you regenerate the GUI, it doesn't change anything in your code. So got all that up and running. That's about it for the week. Back to the group.
Well, fine business. And I think we're gotten everybody on the list and not skipped anybody. So unless somebody speaks. Oh, sorry, Joe. Go ahead, Joe.
Okay. I've been kind of busy with recovering from fire evacuation instructions, and we didn't have to evacuate, but it looked awfully close. So all sorts of stuff piled into the car, the irreplaceable stuff, and been slowly putting that back in. There's been discussion about time of flight of the signal from various sources. and the WWV provides a pretty good solid signal, and we can assume that they're very close to being on time. So what I did, I went ahead and the problem is the digital signal processing in most modern radios has a fair amount of delay. My Aircraft K3 has like 15 or 17 milliseconds of delay. And this adds a lot of confusion to the time of flight measurements. So what I did, I went and took a grape receiver and changed the oscillator from 9.999 megahertz to 10 megahertz. And if I could share my screen here, Dave, here's the result.
I don't, but Nathaniel can.
Oh, okay.
Yeah, it should be open. Everyone should be able to share.
So anyway, are we sharing or not?
Well, you have to.
Yeah, you
Go
have
ahead.
to press the green button on the bottom of the screen, and then you have to select which display you want or window you want to share, and then you have to hit the share button.
Okay.
There you go.
Okay. What I did, I took the WWV receiver signal, 10 megahertz, and as I say, I changed the Leo Bodnar from 9.999 megs to 10 megs, so I get a regular audio tone out of that. And here is the 1 PPS from my Leo Bodnar coming in. Actually, this is the 1 PPS directly from the Leo Bodnar. Here it is going through the grape receiver. There is essentially no delay there. It's less than 100 nanoseconds. And we're dealing with milliseconds here, so nanoseconds is kind of insignificant. It's probably more like about 40 or 50. And it's almost exactly 3 or 3.05 or 3.1 milliseconds from the 1 PPS to the beginning of the WWV tick. So that's what about 525 miles gets me. Anyway, this worked out fairly well, and I'll be presenting this at the Thursday meeting. I had a little interlude in between. I've got cataract surgery again tomorrow. Jim, with your filling up the memory, just wonder, are you saving FL Digi data, or are you saving the sound recording data? That eats up a huge amount of time. And somebody had mentioned center drilling using a small drill. I do a fair amount of machining, and one of the tricks is there's something called a centering drill, and it's basically a small drill with a 45-degree cutting edge after that. And these are pretty large compared to the size of the drill. And you can make a very accurate small hole and then enlarge it as much as you want to with the basically the countersink following it. So if you're having trouble getting drills to be exactly in place, look into getting a couple of centering drills. They come in a variety of sizes. I get mine from either the local machinery store or a little machine shop out in California. And that's it, Dave. Thank you.
Fine
and can
business.
you unshare me, or how do I unshare myself?
I think you can just put.
I got it for you.
Okay.
And I think that's everybody on the list. So we're open for general discussion.
I'll just mention our experience with storage on Raspberry Pis, since we do a lot of real-time data acquisition, is that the SD card shouldn't be used for everyday data storage. It's not really designed for it. It's designed to run the operating system. We first tried using thumb drives and found that they are not good for real-time use, because they have times that they just kind of go off and do their own thing and then come back. So we were getting holes in our data. The best thing to put on is a solid state drive or a regular hard drive, but those show up very directly in the Linux operating system, and those should be used for actual data storage.
Yeah, that makes sense. But the way the software is configured for the Raspberry Pi, it does store on that SD card. And I'm just saying, when I get it off of that SD card, am I safe deleting all the copies of the files on the SD card?
Yeah, if you have the files saved elsewhere, it should be fine. I'm a little curious though, which data you're saving, because I'm running a 32 gigabyte SD card here on my Grape, and I have been running it since, I think at least since January. I think I've started running it before you did, and I'm nowhere near full yet. So I'm a little curious what you're running.
Now, the thing that's taking the space is the CSV files from the second by second data that is collected in the Grape 1. I'm just running the standard Grape 1 data. Who was it? John, I think, wrote.
Yeah, which, I mean, I'm looking at my Grape 1 right now, and I think I only have about 668 megabytes of data since January 2nd.
Hey,
Yeah,
Jim,
those files should
I
be
see a
very
V
small.
file.
Those files are very small.
Yeah, they're
should
only
not
like
be
4
filling
megs
up a
or so.
64 gig hard drive.
Yeah, they're about 4 megs each. So yeah, so Jim, how long have you been running your Grape for?
I've only been running it for about 2 months. I've already cleaned out the SRAW data directory once, but there are several other places I found the same data stored.
Okay. I don't think that this CSV data is stored in multiple places. And again, I'm a little confused that you're filling up. You said you have a 64 gigabyte card. As you can see here, I have a 32 gigabyte card. I've only used 11 gigs of it, and that data, the raw data there, the CSV data, is only 670 megabytes. So I'm not sure. I'm just surprised that it's filling up that fast for you.
Yeah, in fact, I only got about 2 weeks since the last time I cleaned it off because I only cleaned out the SRAW data directory, and I've seen it some other places too. See if I can find it real quick.
I wonder if he has a limit on the directory he's using.
No, I look at the card and it is filling up all 64 gigs. It's also in the SXFER directory.
The transfer?
Yeah, and I thought I saw one other place. I have to look for it again. I forgot to write it down. Yeah, S data.
Okay. So
S
I
data,
would,
S raw data, and S transfer all have the same data in it apparently.
okay, I think S transfer and S data and S plot, S transfer should have the same data that's in S data and S plot combined. Because I think the purpose of this directory is to be where you stage up files that get sent to a central server. But if you don't have the correct cron job running, it just hangs out there and duplicates it. But again, the S raw data, I don't think that is duplicate data.
That's where I first started seeing it, first started looking for it.
Yeah.
And I looked further when I filled up that, and it does look like S transfer and whatever that other one I said, I can't find it right now. Do have the same data in it. Yeah, S data, all have the same data as best I can tell.
Right. The raw one has different file names, essentially.
Yes, you're right. It is different file name.
Yeah, I would say that if you hang on to into everything that's an S data, make sure you have a copy of that somewhere. That should be sufficient. You probably want to keep all the S plots somewhere as well. You can make the S plot from the S data CSVs, but then you have to go through that extra step of plotting it, and it's nice to just have the quick look plots available.
Right, those are
big,
handy.
Yeah, how big is your SD card though?
Well, the SD is the 64 gig card that he specified.
Right, that's the only part that confuses me, because as I said, I've been running this since January, and I'm nowhere near filling up my 32 gigabyte card. So I'm running, I think, the same software you are. So that's where I'm a little confused.
Well, that's puzzling me too. I might look and see if I have something somewhere else that I haven't found yet.
Yeah. Maybe we can ask John Gibbons about that on Thursday morning.
Yeah, I think John would know should know the answer to that since it's his software.
Yeah.
All right, but as long as I hang on to that data, the data that's in S transfer, and I do like to hang on to the plots too. As long as I hang on to them somewhere, I've got all the data, right? And it won't hurt to clean off the card.
That's correct.
Okay, that'll get me running for a while, and we can talk to John later about it.
Okay, that sounds great.
Okay, thanks.
You're welcome. And I did want to tell David Witten, I really liked your server where you had all the data collected. That looked very good.
Well, thank you. That's it's rudimentary at this point, but I hope to do a little more with it. But if it gets the job done, that's the main thing.
Yeah, no, but that's what we need right now. Rudimentary is great. And Majid has built out the magnetometer, and I'm hoping to get it installed within the next month or so at my house. So hopefully I'll be able to contribute to it as well soon too. So.
Well, once you know the name of the account y'all want to use, I can create one, and then you can finish the setup and push the data. That's really the only thing. I just have to create an account, and somebody come in, change the password, and do the SSH key exchange, and then it'll should work after that. So let me know when you know that, and I'll be.
Yeah, I will. It'll probably still be a couple more weeks. I keep getting dragged down with lots of paperwork and papers and things like that. But
yeah, I'm not going anywhere.
Okay, that's good. Don't go anywhere.
It clearly worked well, and Dave's instructions worked. And if I got it to work, anyone can get it to work, because I'm glad if I get anything to work on a command line.
That's good.
And Dave helped me get it set up today, and it worked perfectly.
That's really good. We did. I'm glad to hear that. And we did hear Jonathan was able to come out to my house last weekend, and Jonathan and Majid both came out. So we found where we want to put the sensor. It's just going to be, I think, a good amount of trenching or digging, so to get that actually done.
There's actually going to be one. At least I keep thinking I'm never going to touch the code again, but the Run Mag program, which is not really the one want to be working on. I've come to the conclusion I have to make one more change to it, one major change, which would allow it to write simultaneously to a pipe, so that I can run. So then I can pipe that out to a WebSocket, and then I can do the continuous data plot on somebody's. I can do a WebSocket thing, and it just needs a way to write to two locations at once instead of one, and so I'm going to have to add a command line option. So there will be another change, but it should be. It'll need a few more days.
That sounds just fine. That sounds great. Scotty, did you have a chance to see that email from John Ackerman about timestamping?
Yeah, I sure did.
Yeah. Did you have any comments on it? I mean, it sounds like he basically said that getting the timestamping down to 50 nanoseconds is about what we can expect.
Yeah, and I agree. I think that we can do that.
That sounds good. And
he's the timing expert, so I defer to him, but everything he said looks like it's no problem.
Yeah, that's good. And if we were to put the 10 gig E and the better FPGA on, how much money do you think that would add to the?
I answered your email, by the way, just before the meeting here, but
yeah,
I didn't have any specifics as far as because the 10 gig E adds an awful lot of expense just in the 10 gig E module itself. Yeah. Although I guess in the old days, 10 gig E modules were like $500, but they aren't that anymore.
I mean, are we talking like adding $1,000 to the total cost for a better data engine?
No, I think it would be less than that, because the FPGA, you're going to have to pick one with transceivers to do the 10 gig E. So that's going to be more expensive. You're probably going to need some beefier power supplies, so that's going to change it a little bit. Yeah. And then of course you're going to need the 10 gig E module itself.
Is it easier to get 10 gig E modules than gigabit Ethernet modules these days?
I'm not sure. Of course, we don't need any gigabit Ethernet modules because we put it on board. So
there's a lot of 2.5 stuff out there these days too.
And there's a lot of different kinds of 10 gig E. I think you can do short range, long range. You can even do copper for some applications, for short range applications, or for testing, or desktop type of thing. The main thing I think is going to be the biggest thing. We're going to have to change the form factor, I think, because I don't know how we're going to. I mean, we've got to be able to plug a module in. So we're going to. I don't know how it's going to go. Whether it's going to go on top of the board. I mean, if you look at our stack up, we don't really have any room, because the RF modules take up the whole bottom. The clock module and the leaf module take up about half of the top, and the rest of the top has connectors and other stuff on it. And the 10 gig E modules they're not small that I remember. They're, 3 inches long, maybe by 1.5 inches wide, maybe an inch wide.
So that's going to add a lot of expense, just changing the form factor.
It's going to add a lot of NRE, but when you ask for expense, you're talking about, well, how much is it going to increase the cost of the data engine to get the high performance model?
Yeah.
Well, I could say, since we're aiming for a $300 price, which we may or may not get to, we may get very close, you could double that cost. I mean, you could easily double that cost with the things that we're going to add. So you could end up in the $600 to $700 range for the data engine, but for the performance that you're going to get, that's not really that expensive.
No, and that's the thing. Did you see Dave Typinski's comment on the cost? He said if you get something that costs $2,000 that does what he wants it to do, he'll be really happy.
Well, we already exceeded. I mean, not exceeded. We already exceeded his expectations, shall we say? Because I don't think you could buy the top of the line, all the components for TangerineSDR, and you're not going to spend $2,000.
Yeah, no, I know.
You're going to be south of $1,000.
Yeah. Right.
So.
Yeah.
even with the high performance GPS and, you know, and 2 RF modules and
No,
all that. So
I know he's really excited about that, but that's why it seems like the big limitation is really the bandwidth from the Ethernet and the FPGA.
right now, keep in mind too, we have a 5 gigabit bandwidth USB connection.
Yeah, but
So I
I've
don't
heard
know where
I've
that
had
could-
people tell me that the USB connection suffers from latency problems that you don't have with Ethernet.
Yeah.
And so isn't that going to be a problem? Or people seem to say that's a problem.
I don't know. I mean, I haven't really. The 3. Ethernet, the USB 3.0 was put in kind of as an afterthought because it was something that the one of the Lime SDRs had, and it was very inexpensive. And I thought, well, okay, I'll put this in as a backup channel. That makes our receiver one of the only ones in the market today that has both Ethernet and USB 3.
Mm-hmm.
Now, as far as what do we do with the streaming, I don't know. Can the Raspberry Pi keep up with the USB 3 stream at 5 gigabits per second? I mean, I could send the entire spectrum over that bandwidth.
What if you got rid of the USB 3 and used that space to put on the 10 gigabit Ethernet?
Well, it's not that easy because the 10 gigabit Ethernet requires a different FPGA because we have to have the high speed transceiver ports on the FPGA to talk to the 10 gig.
Right. But
And
does the FPGA, is a different FPGA different form factor?
not necessarily, but it's not being a Max 10, it doesn't have internal memory. So you have to put external memory on it. And it's a lot different. So
yeah, so you're really talking, so really to do this, you're talking about a totally different data engine.
yeah.
Okay.
But a lot of what we have just migrates over, but some of it doesn't.
Yeah.
So like the 10 gig E doesn't. The 1 gig E, I mean, I don't know if you'd want to keep the 1 gig E port also, or whether you want to replace it with the 10 gig E.
Yeah, why? Well, it's 10 gig E. Is it backwards? I haven't worked with 10 gig E before. Is it backwards compatible with 1 gig E?
You know, that's a good question. I don't know the answer to that.
I mean, I'm guessing it is because when I've Googled 10 gig E equipment before, it looks like it's just an RJ45 jack.
Well, yeah, 10 gig E, there's a couple of options on it. One is RJ45. And you can get reasonably good reach on Cat 6A cable on the order of 45 to 50 meters at 10 gig E. More, there are also the other interface is SFP plus, which is a different form factor, and that will support plugins that will give you copper, RJ45, and fiber. It's pretty much plug and play, just like Ethernet is, but you'll find the RJ45 ones dissipate a fair amount of power, 3 or 4 watts, and they have quite a bit of latency.
But can we run the 10 gig E interface at 1 gig if we don't need the speed? Is it backward compatible like that?
Sometimes. It depends on the chipset you have, whether they'll negotiate between 1 and 10, or whether you have to manually force the interface speed. So sometimes it'll auto, sometimes it's manual.
Because it would be attractive having a 10 gigabit data engine, 10 gigabit Ethernet data engine that would plug into a gigabit network using RJ45 if that's the only thing that was available.
Well, you know, once you abandon the form factor that we have, all things become possible, and you can put the card, the plug-in card, you know, anywhere you really want alongside the RF modules, except, I mean, you got to be careful of interference issues and not creating noise, but it's, you know, you can make the card significantly bigger and still put RF modules on. In fact, maybe we could make the upgraded data engine have only 1 slot for RF modules. Although I would think adding—
Why would you do that?
For space reasons. But
Yeah,
I think for performance reasons, though, I don't think you want to do that.
No, don't do that. If you're going to make a better data engine, make a better data engine.
Aren't you at the very limit of what you can do with the if you're going to go to FPGAs that have SerDes channels, wouldn't you be better off going to a mini PCIe interface to like the radio and so forth with a protocolized interaction rather than and then have the boards be interchangeable with other things rather than, I mean, you almost have a total redesign, it seems to me, if you went with a different.
Well, if you just take the 1 gig E and substitute 10 gig E for it, it's not a total redesign other than the requirements that you put on the FPGA that are significantly higher now. So you're going to need a more expensive FPGA and a more power hungry FPGA. But
I see that.
But if you go to PCIe, and the thing is too, if you use a more expensive transceiver-based FPGA, you can put a PCIe interface on the card also.
Well, that's kind of what I'm saying. You'd get around all these hoary limitations you've had getting stuff on and off through that M.2 connector. If the interaction, if you had a control channel that did stuff like I2C and real slow stuff, but it was going through a very fast channel. You could, but you'd have to rethink the whole design.
Yeah. So what you're saying is to replace the RF modules with PCIe modules. Is that what you're?
Yes.
Okay. So then you'd use standard modules there, and yeah, and of course that was kind of the hope that I would not have to do that, because we're going to have lots of RF modules out there eventually, and I would hope just not encourage people to throw them away. But like you said, you have to sit down and think out the whole system. And
but this whole thing has been designed at the extreme limit of what the Max 10 devices can manage. Right. And it's not even clear that the Max 10 line will even exist in a couple of years. It wouldn't seem to me, certainly Intel's not putting any effort behind it. Doesn't seem like.
Yeah.
And it's old technology to them.
We can all worry about that, but when I can still buy a Cyclone 2, I'm not too worried about it. But
but you can't buy these.
They can always discontinue stuff on you. I mean, anything can be discontinued. Yeah. I'd be more worried about the DRAM than the FPGA, but.
But I'm just thinking that the overall architecture is, trying to keep compatibility with things that it's not, it's historically not really even compatible with the older designs for HBSDR and such. By you're not really, and then you're hindering the overall architecture by trying to, you're making it proprietary to this design, but I don't know that you're going to make it any more long-lived.
Well, I don't know that you're going to do anything other than proprietary. I don't see any whole raft of PCIe RF modules. I mean, there's a couple that exist, but
there are some. I've found them.
But and I think when we get this going and we prove that the RF boards actually perform the way they were designed and they're low noise and we don't have any interference issues with getting the digital noise into the RF modules, that alone is worth maintaining the modules the way they are for at least the time being. And while, yeah, you're right, if we go to a super high-end FPGA, maybe then the module interface is going to be our limiting factor. And it's time to look at the module interface. But at that time, it's time to maybe go to TangerineSDR Model 2 and not keep enhancing the existing one. But I think we have a ways to go first.
Yeah, the modular interface is very attractive because you're able to accommodate so many different types of.
Well, and we've left
still talking about a modular interface, just a different one.
Right.
Oh, I see.
And we've bent over backwards, Tom and I and et cetera, all of us, in trying to define this interface so that it's flexible enough that we can accommodate much higher performance RF modules in the future if we want to.
Right.
Realistically, we're not even using half the bandwidth, and we're using 0 of the transmit bandwidth on that connector. So
But you're using all the pins.
I'm using half of the pin, a third of the pins.
I thought you didn't. I thought you've been
No.
scrambling.
I'm limited by the FPGA, but on the connector, I have plenty of expansion space. And actually on the FPGA, I have connected those pins all up. So
That's my misunderstanding then.
Yeah, so we have an LVDS transmit port that's 14 bits wide differential. We have 2 17-bit input ports for ADCs. We're using one of the 17-bit input ports, and we stole a few pins off the second one to do I2C for the ADCs, but you wouldn't have to do it that way on another board, because again, those pins are all programmable. So if you need 2 17-bit input ports for 4 ADC channels, we could do it.
But it remains you can't go to another. You can't go to 10 gig without probably going to a different family of FPGA.
Right. Really, I think the slow part of the whole design is the Max 10.
Yeah,
it's going to be the limiting factor.
I think so too. That's kind of what I've thought all along.
Scotty, you have experience with a Cyclone 5. Is that capable of doing the same thing?
There are variants of the Cyclone 5 that have transceivers, and I believe we can do 10 gig because you need 2.5 gig channels, because 10 gig is 4 channels of 2.5 gig, and you can buy Cyclone 5s with 2.5 gig. In fact, you can buy them with 3.125 gig channels. So yeah, you can do 10 gig on a Cyclone 5, but you got to pick the right variant.
Yeah. Is there any advantage to the Cyclone 10?
Cyclone 10 is a smaller geometry.
Oh, it's smaller.
But so the advantage will be maybe more logic elements. So I wouldn't rule it out. If as soon as you say that the cost isn't the primary factor that was on this one, now I would say let's get the most LEs that we can get for a reasonable price.
Right.
And yeah, that'd be better than going to something like an Aria or a Strat.
That's what it was. The next solution is go up a level in FPGAs.
Like
And those are substantially more expensive.
Yeah, and we have another customer that we're looking at hooking up a high-speed DAC to an FPGA. And really, the logic that I need is nothing. The smallest one will work.
Right.
The speed of the interface is not nothing. And it just won't work on most of the applications. So you end up having to go to a Stratix 5 or Stratix 10 just because I need the speed on the I/O interface.
Okay.
You know, I need 600, 800 megahertz LVDS. You can't do that on a Cyclone 5. You can't, maybe a Cyclone 5, but, and if you want to do like GSD204, you're not doing that on anything that's a cheap FPGA. So, but when you say, I mean, Nathaniel, how expensive is expensive? Suppose we made the DE $2,000. Is that going to be prohibitive? I mean, because we can take.
It depends on whether you're talking about hams or scientists.
Yeah.
Right. Yeah.
And I mean, I like the idea of having an entry-level one with the Max 10 on it that can do most of the things, most everything that we need, but maybe not quite all the things that Sarah needs. And then we say, okay, for you guys, you get a Cyclone 5 with a 10 gig E interface on it, but now it costs $1,000 instead of $300.
Yeah, I think what we're doing right now is exactly what we're supposed to be doing for the ham community and the personal space weather station. But I think we're quickly finding that there are these other, customers that, really just they're like, yeah, $2,000 is no object for this. Like, give me something.
Well,
give me something that's.
If that's the case, the scientists can buy equipment from Hewlett Packard and Keithley. I mean, you can buy commercial grade equipment if they got big budgets. We don't need to design it for them.
I mean,
more like 50,000 to 100,000 instead of 2,000?
No, I mean, budgets are not that big.
Right.
Depends on your grant.
So, I think there's probably a sweet spot, right? Because if you're what like Dave Typinski and a lot of radio astronomers are very interested in being able to get large amounts of bandwidth through. And if the main, and like Dave Typinski is looking at this thing, and he's saying the main thing that's kind of holding up the show here is the bandwidth throughput that's due to the FPGA and the gigabit Ethernet interface. Well, now that we're seeing gigabit or 10 gigabit Ethernet come down to reasonable costs where it really wasn't in the past, like now it's starting to make a little bit more sense to
Well, and
look
that
at
was the reason we picked gigabit Ethernet, because it just scales to 2.5 to 10 to 40
Yeah.
to 100. I mean,
Yeah.
think down the road in 2040, you know,
Yeah.
100 gigabit might be the PC
Well-
standard. I mean, you don't know.
So,
But the
I
oth-
mean, if you're able to take the, if you were able to take the data engine you had today and just swap out the FPGA and the Ethernet chip and suddenly increase the bandwidth substantially for just another like $300 to $1,000, that I think is something there people.
And
some
that's
people
kind of where I was going with the,
Yeah.
the next revision after we get this going and people are experimenting with it on it. And if you want to keep going with the hardware, 10 gig E is definitely the logical next step.
Right.
And bigger FPGA to support that will be required. And then more logic to support, onboard FFTs and, whatever else the algorithms that they want to implement in the fast FPGA versus the slower general purpose PCs. Although general purpose PCs are going to be pretty fast, but I can still beat them on specific, if you got a specific algorithm that I can implement.
Could I interject a reality point here? If you look at the Edis research site, the cheapest gig E network box that they sell is over $2,000.
That's for gig E or 10 gig?
That's for gig E. The cheapest 10 gig E that they sell is $12,000. Now, the FPGA and the data acquisition may be higher than what we're targeting here, but a data engine at $1,000 with gig E or 10 gig E for $1,000 is a bargain.
Yeah.
Now, whether hams are going to buy it, that's another question.
Yeah. And yeah, so I think what we're doing right now is great to target hams because it's inexpensive, does a reasonable job. It's going to make a great personal space weather station, and it will do most of what the Sarah guys want. And he seemed to want 20 megahertz worth of bandwidth, and I think we're right at the edge of being able to do that.
Right. Yeah.
So I mean, if you wanted 40 or 50, no. But 20, I mean, that's all my calculations have shown that I can give him, if he wants raw IQ data over Ethernet, I can get pretty close to 20 megasamples per second.
Right.
16-bit data. But that consumes the entire channel.
Right. And that's why we were saying, which we've talked about before. I mean, yeah. But I think that other comment about the Edis, 10 gigabit Ethernet box being $12,000. I think, for a scientist, it's not, we can't say that money is no object. But perhaps their budget for this sort of thing might be higher than a ham. And I think, a $1,000 to $2,000 instrument is going to be much more attractive to a scientist than a $12,000.
So, Nathaniel, the other point is each of these are a sample. You were thinking about samples by one machine, but each unit is a sampling point. And one way to improve the quality of the science is have more sampling points with substantial bits of data. So there's a real, being able to buy hundreds of these things versus being able to buy thousands of these things. What's the trade-off?
Yeah.
Well, it's directly proportional to how much they cost, right?
Right.
So they cost $12,000. Most people are not going to buy it.
It's not just the cost of building the equipment; it's also the cost of deploying it. You have people and transportation and
and also
infrastructure and all that.
Keep in mind that Edis Research also has a team of guys working on those radios. So they got a lot of NRE invested in that, and they've got to get it paid back somehow. So the reproduction cost of the 10 gig radios isn't necessarily representative of how much the hardware costs. It can be representative of, I mean, if you've got to have a team of programmers programming the FPGA to get it to function in the high performance mode, it's going to cost you more money because you got to pay those guys.
Right.
So, and in our case, depending on how many academic groups that we get to do that kind of work, we don't have to pay as much because it's done under research grants and things like that. So maybe, and like with Tapper, when I tell you a data engine is $300, you provide the firmware.
Mhm.
You know, so I mean, you're getting the hardware, you're getting the empty box,
Right.
but it's so, and the firmware is going to be provided by all of us who are going to then build up
Right.
this.
Right.
So, and the same with the software that puts it, that makes it actually, so it can be part of this network that we're building.
Right.
Well, I just wonder if we can easily stray outside of our mission here and start designing things that really are aimed at the scientific market. Is that really?
Is that what we want to do, you mean?
Is that really our mission as a
That's
team?
what we call phase 2.
Yeah, but also Scotty's running up against a limit of availability of parts. Is it worth it waiting 2 years for the parts?
Well, by then the grant will have expired, and we'll just have to give the NSF a report that says, here's theoretically what we could have done if we could have gotten the part.
I'm not going to be that pessimistic. Okay,
To me, it's clear we continue with the current design because of all of its applications.
I mean, we have 18 months.
And we can look at a phase 2 later, but we got to get something working first.
Yeah, I agree with that.
I have to look at this as a temporary situation. Otherwise, I might as well just go like take up basket weaving or something. Because, you know, I mean, everything that I do requires those parts. So what can I do if I can't get them? Well, basket weaving, you know.
Well, I guess you got to talk to your guy at Intel and say, well, what are you going to be able to get for me?
Yeah, that's another thing. You're right. You can build, and this is what we've done in the
And
past.
build to what he has available.
Well, and I guess that's kind of where I was going with my question too, is you know, what are the 10 gig parts in the better FPGA? Is that available as opposed to what?
Funny you should ask, because the higher performance, more expensive parts are built on Intel's fab line, where the inexpensive parts like Max 10s are built on the TSMC fab line, and that's the fab line that's choked up.
Right.
So yes, you can get more expensive parts from Intel more readily than the cheap parts.
So maybe I don't, and I guess does it make sense to do that?
And the thing about it is that we're like 98% of the way there to building this. I mean, I got thousands of dollars of parts sitting in the next room, waiting for the one part that I need to build this. And so it doesn't cost us anything to stop. And once we get all of the design done on this, and I can't go any further at all, and I can't gain anything by continuing to look at it and massage it and, you know, have conferences with Tom and figure out changes that we need, then it just becomes, well, you might as well work on the next one, right? Because there's nothing to do on this one until we get the part.
Right.
And then when it does eventually show up, and I don't believe it's going to be February next year. I just can't believe that it's like going to a new car dealership and having them tell you that they don't have any cars. Well, how long is that going to last before, I mean, there's tremendous pressure to have product because there's people waving dollar bills in your face wanting to buy them.
We saw it with the vaccine too. Like when the vaccine first rolled out, there was like not available. And I know in Pennsylvania, we went for months before it seemed like they were always in phase 1A forever. And unless you're in this category, you could not get the vaccine. And then all of a sudden, and there was like no possibility of anyone else getting it. Then all of a sudden they're like, everyone can get vaccinated Tuesday.
Right. It's like,
it just,
you can't even give it away here in Alabama. They're turning away trucks. So just send it back to wherever it came from. Nobody here wants it.
Boy, that sounds progressive.
That's Alabama, but we have the same problem here in Missouri.
So there's a
Yeah.
tremendous pressure on the fab lines to build a new fab line. In fact, what I had heard was in Tempe, TSMC is building a huge building right a few miles from here. That's going to be a new fab line. This is the rumor that I heard. What TSMC is a fab company, right?
Right.
What would they build there? Not an Amazon warehouse. So it's probably going to be a fab line, and I'm hoping it's going to be like the DRAM was, unobtainium for months, and then all of a sudden, how many do you want for a nickel? Because we got as many as you want. And because it's in their best interest to fix this as fast as possible. So, and I've seen this happen too, is when they don't know how long it's going to be till you get any product, they put in 99 weeks or some long, you know, what the field takes 2 digits. Okay, 99, we'll use that. And I've seen them do this before. And they say 99 weeks, and you say, oh my God, you know, I might as well go out and shoot myself. My project's dead. And then a month later, they have product. So cross your fingers. And it's, I mean, the pressure's on for them to do this.
Do we have an order in there so that when parts become available,
Yep.
they're able to ship?
The order's been in for a couple of months. And in fact, was the prerequisite for going and beating on people, is you got to have an order in, because you can't expedite something that you haven't ordered.
Right.
So, and we have all the parts now except for the Ethernet part, sorry, the USB 3 part and the FPGA. And the USB 3 part, I just got a note from Nona here that says they actually have delayed it. It was supposed to be August, and now they moved it to September. So what that means is in August, they were supposed to get like 16,000 parts in. All that means is that we didn't get our order in soon enough to be part of that 16,000. So now we're going to get part of the second shipment, most likely. But that doesn't matter if I can't get FPGAs. In fact, I can build the board without the USB 3 part. I can build one of them anyway and test it, but I can't do it without the FPGA. So,
right.
So I've been beating on him as much as I can, but he can only do so much. And now this is the guy that we built a ticker tape sign once, and we needed like 200,000 LEDs. And I don't know if you know anything about LEDs, but you can't just go out and place an order for 200,000 LEDs. They want to know what color bin they're in. They want to know what brightness bin they're in. They want to know what current bin they're in. I mean, they're all these, they sort them by different characteristics. And if you're making a ticker tape sign, you really want them to be all the same color, because you're going to build the boards at different times. And if one goes out, you want to be able to replace a board and not have it be bluer than the one over here, so that it looks funny when the letters slide through. So we wanted 200,000 of one bin, and nobody could satisfy our demand. And this guy was the rep for Light On, I think, and he got on the phone and he got the LEDs for us. And ironically enough, the price that we paid less than what we were quoted for the one bin vendor who couldn't do it, which I think was King Bright. They said, "Oh yeah, no problem, we can do it." But then when you go to place the order, well, you can't do it. Not one bin. And so they're trying to split it across bins, and we're going like, no. And so my point was, this guy comes through on almost impossible things, but I think I've given him something more impossible than he can handle, because if this is beyond him, because he can't seem to come up with the parts, even
Scotty,
one part. Yeah,
Scotty, there was one thing that I wanted to mention. Since you mentioned having USB and the latency with USB, I've run into that quite a bit with USB 2.0 with VLF audio capture using a USB sound card. The USB interface would often present a lot of latency and would not provide a continuous stream. Sometimes there would be hangups, and it would actually lose frames of data based on what the USB bus was doing and whatever. that was primarily present on the Raspberry Pi, but it is possible on a PC too. And also for use with PPS signals, USB to serial interfaces also do have inherent latency, which are terrible with if you want to use the PPS signal to discipline your NTPD. And John could also tell you about that too. Me personally, I would think the Ethernet interface is probably your best bet. I mean, maybe there are.
If you want 30 mega samples per second, you can't get it on Ethernet GigE. There's too much data. So the question is, can you get it on a 5 gig USB 3 link or not?
Phil Erickson has mentioned the same things that Jonathan has mentioned before, where it's like that latency.
Well, this is why USB isn't your first choice.
Right.
Right.
But I mean, so I'm like, even if you're able to get the higher bandwidth, these other problems that they say crop up, isn't they
the latency is on input. You wouldn't be using USB for input. You're talking about streaming data out, and you've already tagged it with timestamps, I assume.
Right.
Yeah.
So if you get a little bit of latency between packets, that's okay because you got timestamps that are accurate.
That's true. But what about what Jonathan said about losing packets?
Well, there was a problem with the Pi, the chip they used on the Pi. I don't know if that's a general USB problem or not.
And I would say that there's probably a general problem of streaming 5 gigabits per second to a Raspberry Pi. I mean,
yeah,
you
that's
really
probably
gotta be able to handle that.
Yeah, you're not
There
going to be.
are, just so you know, there are cheap USB 3 2.5 gig dongles on the market, but I don't know if they work with the Pi or if they work at all.
It's just that I'm thinking that the Pi, I mean, it has a limited amount of ability to handle massive amounts of data, and this is a massive amount of data. You may be forced to use a USB 3 port to an i7 desktop or something instead.
Mm-hmm.
Yeah, keep in mind the previous versions of the Pi, the Ethernet was actually a USB device. The Pi 4 changed that. So latency on the Pi 1, 2, and 3 were all tied to USB.
And hence the reason to use an N2. And I think, Bill, you have more experience with the N2 than Bill or Dan. I don't know. I think that the USB 3 on the N2, is that capable of doing 5 gig? I don't know.
I don't know.
But even so, I mean, the processor's still limited. I mean, it's still a sub $100 small computer, not intended to process huge chunks of data. So, I mean, Nathaniel, when the Sarah guys say that they want this huge, big bandwidth of data, this big pipe aiming at them,
yeah,
what are they going to do with it? I mean,
how are they going to capture it?
How much processing do they need?
Oh, they'll provide the computer. They're not worried about that.
Right, but I'm just saying it's not going to be a Raspberry Pi, right?
No. It's not going to be a Raspberry Pi at all.
So the USB 3 that we're going to stream out of is going to connect to a higher performance computer, most likely than the host computer.
Yeah. Let me see if I can show you.
I mean, wouldn't it be? It's kind of like the host computer controlling gigabit Ethernet streams that don't necessarily go back to the host.
But there's latencies and hangups on all of this can occur at many different points.
Yeah.
There's the physical interface that the CPU uses to drain the PHY on the USB or Ethernet. There's the how well programmed the drivers were to get that job done. There's the nature of the environment you're working in, what else it's trying to do at the same time. There's it's just endless ways this can get messed up.
Right, and there's also a lot of ways that you can improve it by say making a dedicated USB controller that controls just this line. I mean, you know, you can optimize it if you need to.
Yeah.
So, and so I mean, I think that we're getting in way overhead if we think that we can just take any old computer and plug it on and have it work. I mean, when you're pushing the limit of compute power necessary, you can't do it that way.
But most of the new chips, and they're coming slowly onto the market, the CPU, the ARM type and things of that class, CPU chips have a lot more SerDes capability. And the Pi ones are way trailers and all this. A lot of the Rock chip ones and the and AMS and all these other manufacturers are, every one of them is putting a lot more of that into each new thing, and everything's rolling off the lines kind of slowly right now, but some of them were out there even before we started this project. And now, you know, because like the Rock chip, the Rock Pro 64 type chips have 4 or 5, I think 2.0 full duplex SerDes, or 3.2, something like that. And then the ones that come from NVIDIA, you know, are way over that.
Yeah.
Keep in mind, the Pi 4 actually has the capability to do PCIe.
Only one unidirectional channel.
It's one lane.
One lane, and I'm not sure it's duplex.
Yeah, which version?
It's real ancient.
Is it? Which
I'm
version?
looking.
That could be only 2.5 gig. I mean, if it's Gen 1.
Yeah. Well, all the others are all the way up to like the NVIDIA ones. Some of them are 4th gen.
Yeah. But then it comes down to the question, okay, so I can get you all the data, but what are you going to do with it?
Yeah, can you swallow it? It's like the hot dog eating contest, you know.
Well, yeah, but I think they would be. I think these people would be happy to provide a good computer that could handle this. Because this is what they're using right now, and this is all like custom built hardware. So they've spent a lot of money and time on this.
So what does a rack like that cost?
I don't know, but it's gotta cost a lot of money.
This looks like the receiver they got on the bottom looks pricey already.
This one?
Yeah, what is that? A 7610? I don't know what it is.
Yeah, but I don't know what that is either. But I think what this basically is, this is called their dual polarization spectrograph. It's a scanning device that scans between, say, like 16 megahertz and 32 megahertz, and it scans I think, I don't know, in channels of 30 kilohertz bandwidth between those 2 points.
But wouldn't we eliminate all of that with our direct sampling?
Yes. Yes. The idea is they want to, and they've got 2 of these things because they're using one they're doing the cross polarization. So yes, Scotty, what you are creating with the Tangerine SDR, they want to basically replace all of this with the Tangerine SDR.
Right, and then the 2 inputs, the polarization will be done with our 2 inputs. Will be detected.
Right.
This is the Sarah people, or the
radio,
SETI people.
The Radio Jove people.
Yeah. Okay.
Yeah.
Okay. So they've got some money somewhere.
Right.
I
think they do a lot.
Most of those are not going to be in the spec closet.
Radio Jove does a lot of very low end citizen science.
They do that too, but this is their I think their higher end group.
Wow.
Yeah, but that project would use our hardware quite readily.
But I think they want the Tangerine SDR to basically replace this. And that's why the guy who sent me this is the one who said, if you, something that's like $2,000 that does everything the Tangerine SDR does would be very attractive.
Because what that rack costs is $5,000, right?
Probably. David McGaw probably has a good estimate of in his head of how much this costs.
Yeah, there's a lot of hardware there. That probably took quite a bit to put together.
I think a lot of these Radio Jove people are actually tied in with University of Central Florida, University of Florida. Oh man,
The Jupiter, Florida branch.
Jupiter, Florida. What's his name? Fernando Reyes. Radio Joe. I met these guys were at what do you call it? They were at Hamcation the last time we were able to go in person.
This isn't the guy that runs the radio telescope in Chile that destructed, is it? Is he the same guy?
He's at Green Bank.
Oh, he's a Green Bank guy. Okay.
Yeah.
Oh, you're referenced,
Yeah, here, this.
Daniel.
What's that?
You're referenced.
I'm referenced. Oh yeah, well, I'm writing this paper, so
he's referencing himself.
Self-referencing.
Well, hey, when you're the expert, you get to do that, right? Because you know more than the. You want to have the most definitive list.
Yeah, Francisco
I believe they
Reyes.
call that recursive.
He showed up at the yeah, Francisco Reyes showed up at Hamcation when we were there in 2019. And so he was there with Dave Typinski.
And he was at the Sarah booth, right? Or was he at the booth that was next door to us?
I'm not sure, but yeah, okay, they're right. See, they're in the Department of Astronomy at University of Florida, Gainesville. So there's a whole group out of there that
because traditionally at Hamcation, the Sarah booth is next to us, and at Hamvention, it's over in the building where HamSci is.
Okay.
I remember talking to them.
Yeah.
I remember talking to these guys.
Yeah.
You do
so
remember
that
them?
I do. Yeah.
So I don't know for sure, but it's possible they have some funding, you know, through this. And they've been doing this a long time.
Yeah, they've been around.
They've been doing this like going through some of their references and seeing some of their names. Like the people that that Dave Typinski is working with, you can find their names in these papers going back to like the 60s and 70s and 80s. So they've been doing this a while.
Okay. But still, you know, when it gets down to it, it's like the limitation that we have is gig E.
Right.
All leads back to gig E, and it doesn't matter how big an FPGA I put on there if I only have a gigabit of data pipe.
Yeah. Right.
So if they want more than 20 megahertz worth of data of bandwidth.
Right. Which is why I mean, obviously I guess this is not possible, but if it were possible to just replace the gigabit Ethernet with the 10 gigabit Ethernet and not do a whole board redesign, you know.
I wish.
Yeah.
We're already running the FPGA at about 110% as fast as it's supposed to go.
Yeah.
So, but yeah, that was a limitation. I mean, I remember this. This is why we picked gigabit Ethernet, because it scales. So the next step's going to be a faster Ethernet.
Yeah.
I mean, even 2.5 gig.
Mm-hmm.
I mean, give them what they need, but I just can't do it with that FPGA. It's just not going to work.
Yeah.
We're pushing our luck as it is.
Yeah. But, and you said that you can't get, you couldn't get a drop-in replacement FPGA that's bigger.
No, Max 10, that's the reason Max 10 is so attractive, because it's all in one package. It's got the ROM built in. It automatically loads the RAM from the ROM, and the other families don't do that, which is not hard, but it doesn't just drop right in.
Mm-hmm.
You have You have to add some memory, and you know, right now on this board, I mean, maybe that's a mistake that we made by backing ourselves into the high density corner, but squeezing the most out of it that we can possibly get makes it very difficult to add or modify, because you jigsaw puzzled yourself in, like on the clock module. If we had to change anything, it's like you can't, because it's just so dense.
Right.
You can't move anything without affecting 8 other things.
Yeah.
And so now the good news on this board is I think we could theoretically take the 1 gig Ethernet out and the leaf module out and put the 10 gig E across the top of the board.
Okay.
That might be possible because the gigabit Ethernet is up in the upper left corner. So you just turn it around, put the connector on the other side, run the 10 gig E that way, your module slides in. It could be a doable thing, but you're still going to have to change the FPGA. And so that changes a lot of the board.
Okay.
And especially, I mean, I don't think I have any examples right now, but when we get to the end and everything's done, I want to show everyone what this board looks like. And it is amazingly, there's a reason why it took us 2 months to lay it out. Because we did pin swapping to make the lanes all flow just nicely on one layer. The high-speed lanes, the differential pairs. The differential pairs are controlled impedance, so you can't just put vias and run them anywhere you want. You have to be careful with that. You have to make sure they're next to a ground layer and maybe not in between 2 ground layers, because that's different than being on the top layer with the ground layer below you. So all of that stuff had to be taken into consideration. And when we change the FPGA, a lot of that's going to have to be redone, because the pinout's going to be different. So, and if you want to preserve all of the high speed data lanes to the receivers, which is kind of the whole point of having this machine, then you're going to have to do this. You're going to have to pick 1152 pin BGA, and you're going to have to route those, and it'll be a 16 layer board, and it'll be a lot more effort. But once you get done, the reproduction cost, I mean, it's not going to be, I don't see it as being none of this stuff is esoteric technology. I mean, it's complicated, and you may not be able to have your local board shop on the corner make it, but it's not anything that is like space grade or anything like that. If you want to make a satellite, that's a lot worse than doing this.
Yeah. Yeah. Well, I think before change topic for a minute, and I know it's getting late, but with the magnetometer, I was hoping to co-locate my magnetometer with my like VLF and HF receive antennas in my yard. Is that going to be a problem, having all that antenna metal out there with the magnetometer sensor?
Shouldn't be. It's not moving around, right?
No, it'll be stationary.
Yeah, no, it shouldn't be.
It's not magnetic either.
Right.
And they're not transmitting antennas, right?
No, not transmitting antennas. Receive only.
Well,
And
it'll be, what I had planned on using was something like a steel fence post, and it's not going to be moving around, but it'll just be in the ground. It'll move around slightly with the wind, but that'll be it. Do you think even slight movement might cause interference?
Yeah. Especially with the steel fence post, how far away?
Oh, I would say like maybe a foot and a half, 2 feet.
Oh yeah, that close, definitely.
Yeah.
Why don't you use an aluminum one?
That's possible.
Or a wooden one.
Or a wooden one, yeah.
Yeah, aluminum, plastic, wood.
And realistically,
but, yeah, steel
fiberglass.
is problematic for magnetometers. It creates hysteresis.
but if you put it in a hole with cement base, how much is it really going to move in the wind?
Well, even if it doesn't move, Scotty, it's going to cause a local distortion of the field.
Even if it's aluminum or wood?
Oh, no, if it's aluminum or wood, no.
But
No, if
yeah,
you have to, or fiberglass, you don't have to worry about movement if it's any of those. Even
So
aluminum.
yeah, on our rockets, they could see the steel core of RG-316
wow.
near the magnetometer.
So in this case, it would be beneficial to probably use like one of those aluminum fence posts.
Yeah.
Maybe.
Nathaniel, don't use copper weld for your antennas.
Right.
Isn't that a steel core?
Yeah, copper weld steel core. Yeah, and you want just straight copper.
I want to put it right here. So I would put, I can annotate. Right there is where I'd put the antenna and the mag sensor. So that's my house over here.
But the antenna was a long wire, or what kind of antenna?
The antenna will
go ahead, John.
The antenna will be enclosed in a PVC pipe. What I'm using is copper tape taped onto the outside of pipe insulation, that foam pipe insulation, and that is fed into the pipe, and then I'm going to solder a wire to that copper tape, and that's going to go to the board for the antenna.
So it's like a cylinder then.
Yeah, it's very thin
cylinder.
Very thin cylinder of copper tape held in place by foam pipe insulation.
Yeah, if you don't have a closed loop, don't worry about it.
Okay.
What's that? What was that, Jules?
If you don't have a closed loop, I mean, if you had let's say a copper loop that was closed with low resistance, any movement of that will cause a change in the magnetic field.
But if it's just a whip, not a problem.
But just what Jonathan's describing is fine.
Okay.
Because one of the things here is that to reduce wind noise, the antenna has to move a little bit with the wind.
And that's okay.
Okay. And yeah, on the map there that Nathaniel put it on there, that red line, that's where the conduit is going to be laid.
You're going to lay on the ground? How high up is it going to be?
No, it. Oh, go ahead.
I guess another point is that this is out in an area we mow this field. I guess every time we mow, that's gonna throw off the magnetometer, isn't it?
Well, just for the time you're mowing, yeah.
I think I posted on the list my results from mowing, and it's pretty minor. There's some spikes, and it didn't seem like a big deal. I don't know if people saw that post, but it's obviously going to affect it greatly. But it'll be a fairly quick spike and then gone.
Yeah. I could also, yeah, we don't necessarily mow this area over here so much, or I mean, we've got all this woods too, so I could stick it in the woods. It would just be convenient to have everything all in one location.
And the thing about the lawnmower is that when it's by the VLF antenna, it's going to pick up the spark plugs.
Right.
One thing that I've noticed, I was using the VLF receiver in my car the one time many years ago, and I was holding it and I was grounding it as a counterpoise, and there was a car parked next to me, and someone started the car, and I heard the whine of the ignition system in the VLF receiver. So that would be pretty interesting to hear what it what the lawnmower ignition sounds like. But obviously, with the lawnmower by there, that'll cause interference too, since it's a heavy metal body.
You need a diesel lawnmower.
I mean, even when I start a car, you can see it in the magnetometer readings, but I mean, assuming that could be filtered out, I mean, in the reality of life and anyone who deals with data is that there's noise and interference, and you just have to deal with it. I mean, obviously everyone strives for having perfect data with no interference or artifacts, but that's not very easily attainable. And so I think, I mean, I guess I hope that, and this is what I've been trying to do, is just sort of quantify or at least qualify what various influences look like, and that gives someone some data, an end user who wants to filter it out. And I mean, I don't think that should be too hard. Maybe I'm wrong there, but
I'm sure Hyman could provide us some information on that too.
Well, I mean, a lot of it is going to be with all the citizen science data, we're going to have to deal with that problem. Like,
sure.
There's no way we're going to guarantee that everyone's data is clean and pure and whatever. And even with the professional data, it's true that doesn't happen.
Statistically, that should fall out, right?
Yeah,
because it's not correlated with anything.
Right, and one of the advantages of doing a distributed array network and the way that you typically analyze ground magnetometer data for space physics is you're often comparing what you see at one magnetometer with what you see at another magnetometer. And so, yeah, if they don't match, it doesn't carry as much weight. You're often looking to see how a disturbance propagates from one area down to another area.
So if many match, then that carries a lot more weight than just one outlier.
Right.
Off.
You're looking for certain patterns. So yeah, if you see someone mowing their lawn for a few hours here, and you don't see that in any other magnetometer, well,
and the signal is fairly clear. I mean, what is it?
We'll probably get
falls off at the square or cube. And you can see that when I make passes around my lawn, you can see the spikes fall off at,
yeah.
How about you just turn it off when you're mowing?
Yeah.
Just like we talked about turning off your magnetometer when you're transmitting, because it's a known interference mode. I'm gonna transmit.
But
now.
I think in practical life, it's going to be very hard to guarantee that everyone's going to do that. And I mean, like, and even for me, it's like, okay, let's say I have, 5-10 minutes. I want to get on the ham radio. Okay, now I have to spend 10 minutes turning off my grape receiver, turning off this other receiver, making sure my magnetometer is off so I don't interfere with any of that. Then by the time I do that, the DX has gone away, and then I have to go, where I'm out of, or my little break time for operating the radio is done, and I have to go turn everything back on.
This is why I don't get any bike time, because it takes a half hour to get ready for 15 minutes of exercise.
Right.
So it's not worth it.
Right.
Yeah, the basic stuff is
push mowers.
This is right. It's transient stuff that doesn't correlate with anybody else.
Yeah. So I mean, I think it will be fine. It'll have to be fine. And it's often very easy to tell the difference between like man-made signals and geophysical signals. Like when I'm looking at the ham radio data, trying to see, do we have an effect caused by, say, a solar blackout, or something caused by, say, a geomagnetic storm? It's often easy to look at the data and be like, hey, that looks like it was man-made. It's just too sharp or too whatever. Just so you can see a lot of that.
So you're just going to have to submit a sample of your lawnmower so we can generate a signature of it and
push more.
Well, the data analysts will probably The data
push note,
analysts
yeah,
will
push
probably get
note,
very
yeah.
good. Yeah, the data
push-
analysts will probably get very good at recognizing lawnmower signatures.
Yeah, the problem is, well, at least with respect to the magnetometer, Dave, the problem is a push mower is steel. Unless you get a all plastic or all fiberglass model or all aluminum model, and you're still going to see the change.
Well,
I
we
got
should
an
have
idea.
a-
Why don't you get a goat?
Yeah, a couple of goats,
might
that's
do
all
it.
you need. Or
That-
sheep.
Yes. So
That might be the
So
answer.
now we're going to tell all of the personal space weather station, all the people who want to be involved in the personal space weather station, that not only do they have to, buy all this equipment, but you also need to turn in your lawnmower and get a goat.
I would take
Keep it away from tin cans.
I would take anything, any official document that you can come up with that would give me something I can send to the city to tell them to kiss off when they tell me I got to mow my lawn. I'm sorry, I can't do that. I'm collecting valuable space weather data. You can't make me mow my lawn because I would interfere with it.
Well, also, don't you all, if you have a goat, don't you also have the problem that they will eat coax? I mean, so if you've got coax running out to your antennas.
Yeah, sheep is a better deal. And plus the fact you get, well, with the goats, you get milk. With the sheep, you can get wool and then take up a spinning hobby and make your own clothes.
But you just need to hire a shepherd to keep them away from the coax.
When I was in Norway, I got to visit my friend Ivan, and my favorite conversation was when I was sitting at their breakfast table, and my friend Ivan was arguing with his mother, which are better, sheep or goats. And Ivan, who's about my age, he was all for the goats, and his mother was all for the sheep. And Ivan was just saying that the goats are just so much more fun and more entertaining.
In the Western U.S., didn't they have range wars over cattle versus sheep?
Versus sheep, yes. Yeah, I speak from experience because we had 3 sheep for a number of years when our kids were growing up and got a lot of wool and did a lot of spinning.
Supposedly sheep tear the grass out and cattle chew the grass off. So sheep are more destructive to the environment.
True.
Now, the problem with cattle, though, is they often have cow magnets in their stomachs. So isn't that going to?
Oh, that would be bad.
Yeah.
I mean, the reality is that scientists, I've dealt with tracking data, and you're looking at GPS data, and you're tracking an animal, and let's say it's in New Jersey, that's where I grew up, and then all of a sudden it shows up in Siberia. Then you filter that out, and that's an extreme example. But anyone dealing with any kind of data is used to dealing with outliers and strange things happening, and so I just don't think it's such a big deal. I mean, it's anyone who deals with data has to deal with this routinely.
I think you're right. I think it's late. We're all getting punchy.
Yeah.
I do agree.
When we start talking about sheep, I mean, forget it. It's time to go.
I remember learning about some of the old space physics data, and they used to mark down the letter C at certain times in the data logs, and that meant cows were, over the instruments. So, and I did, and I also remember, when I would go out on the Super Darn Radar repair trips, the Super Darn Radar out in Hayes, Kansas is in the middle of the cow pasture there. And I think the one at Blackstone, Virginia is as well. So you'd always have to make sure that when you go into the radar set, you always have to close the gate behind you to make sure you don't let the cows out.
I did a field day once at a cow pasture and came out of the tent in the morning right into the face of a cow looking at me. And I can tell you the worst thing about doing field day in a cow pasture is not the cows. It's the insects that are attracted by the cow byproducts that are nasty.
Yeah.
And watch out for the bulls.
I have a question.
Okay, Nona just came in. She has an update on the clock module parts. I thought we had all of them.
No, that TX part.
Oh, the oscillator?
Yeah. I talked to Allison. She is contacting the factory. She has not gotten an answer back from the factory.
Because these were ordered with 2-week delivery from in stock.
Yes.
And we still don't have them yet, and it's been a month. So, and this is the replacement oscillator that we're using when we were using a Raycon oscillator originally, and the Raycon guys backpedaled and said that they couldn't make it. So we switched to a Vectron oscillator, which is better actually, but more expensive. And they said they could give it to us out of stock, but I haven't seen them yet. So so we really don't have all the parts in our hands. We're still missing that other one too, the crystal oscillator, the TCXO for the clock module.
Right.
And the ones that were on back order 59 weeks are now out 90 weeks.
Which ones are
It's
the?
just, I'm just so frustrated, guys, because I thought I had this all in hand, and now it was getting close to the time that we were supposed to get them, and now they're pushing them out even further. So
Well, which ones are these? We have everything else.
no, that was for another.
That was for the USB 3 part, right?
Yeah.
You gave me a note the other day how they moved it out further. So
Yeah. So
when I have them all in stock and they're in my back room, that's the only time I'm going to know that I'm ready to build it.
Right.
I don't trust anything that they say.
No.
The vendors say. We had one. We actually, for another project, we were with a shortage of little fuse PTCs. So the customer asked me to order some extra ones because they're going to do another run. And I'm not even building this board, right? But they asked me to get the parts because we're very fast in reacting. We found the parts in the UK. We ordered them, and they came back a week later and said, "Oh, sorry, those were sold." So we missed. We didn't get in early enough to get them. They had 100 of them in stock, and I ordered 10, and I didn't get them.
Wow.
So this is insane. You can't run any kind of business like this. Good thing we're not in business, right?
Yeah.
Yeah, well, we kind of are.
Yeah.
I had trouble getting some 48-volt DC to DC converters back ordered until August, and some 2-pole gas discharge arresters back ordered until September.
But you ordered them anyway, right?
Well, I found a replacement, and I'm going to use 30 volts instead of 48 volts. But
by the way, we ordered your ADCs,
and they're on hand, right?
Not yet.
Okay.
They're back ordered, but we've got an order in, so we're in line.
Okay, good.
I don't know what the delivery time is, but we ordered them anyway because we figured if we don't order them, we're not in line. So by the time they come available, it'll be even longer. So, and I think it was September that they were supposed to come in.
What about those on semi LDOs? You ordered it enough of those, right?
Are those Are those not available now?
Well, no. I was just wondering because since we'll use one for the VLF module, I just wondered if you ordered enough.
I don't know if we ordered any extra for the VLF module because we didn't have any trouble getting those. So we just made the ones that we wanted to get on the list, so to speak. That's the ones we ordered because they're long lead time. Of course, tomorrow everything else changes to long lead time that was short lead time before. So, I mean, we didn't order a whole bomb. We only ordered those parts because we knew you needed them, and that was the part of choice.
Right.
So
Yeah.
if you can't get those, you're really like me not getting the FPGA. You're out of luck.
Right. Yeah. Well, no, that's fine. I'm sure that those regulators, they'll be easy to get to, and I don't have the bomb. I don't have the bomb done yet. So
we actually changed the RF module to use 2 of those small low noise regulators in place of the LM333, whatever the heck they were, the SOT 23s.
Yeah.
And because I needed the space on the board, because we're adding an extra regulator. And last time I looked at DigiKey, I mean, they had like 20,000 of them. So I don't think we're going to be in trouble. In fact, there was one capacitor I was looking at. They had over 2 million of them in stock. So
Oh, nice.
I think it's safe to use that part.
Well, what about those protection diodes that are on the front end of the RF module?
The
Those-
GL03Cs.
Yeah, those TVS diodes.
Yeah, well, I have a secret stash of those, so I don't worry about those.
Okay.
Because we built a previous board that used that same part. And back then, you don't have to do this anymore, by the way, but back then you had to buy a reel of 800. So I
Oh.
think we actually have 2 partial reels stashed away somewhere. Finding them, not so easy, but I know they're there somewhere.
Well, so the way you use them, and the way I would use them is I would just put them parallel to the input.
Shunt the
and then,
input, right.
Yeah, and then the other input to ground. And there's no other passives that I would need. Just attach them right to the input, and then.
Okay, and they're like 3 puff or something, really low capacitance.
Okay. All right. So yeah, I was because I was working on the input circuit, and I was adding those, and I was wondering if there was any other components that you'd recommend with
Well,
those TVS diodes.
When you add a component like that, just go figure out, go to DigiKey, go to Mauser, and see if they have them in stock. And if they don't, then you can bet you're going to run into trouble.
Well, no. I was wondering if you recommended any other components along with those.
No, on the front end, no.
Yeah. Okay.
And I mean, you're going to have external circuitry on the front end anyway, because you're not going to go, I mean, you're going to go to some kind of amplifiers, right?
No.
I thought you're going to have different band pass amplifier filters and amps on the front end, external to the board.
No, that was for the Cirrus Logic part.
Oh.
For this, a lot of the reference designs and even some of the audio designs that I've seen, the audio is fed directly into the part.
Okay.
This way, there's no, I mean, because we could add some filtering later on, and I was thinking about like 60 hertz filtering later on, but for the time being, I'm only just going to put the diodes.
I think generally the less you put there, the better off you are.
Yes.
Just to protect the front end is what you really need from whatever environment it's going to be in.
Yeah, and if I do add notch filters for 60 hertz, it's going to be that's going to run into issues because depending on the values of those passives, where that notch is, I mean, it'll be, sometimes it could be at 59.9 or 60.2, and it doesn't really work that
well, make it broad enough. Make it broad enough so that it covers 59.9 to 60.2. Then you don't get as deep a notch, maybe, but
well, yeah, that's
because it's
something
going to be at 59.8, and you're trying to notch 60, and it's very narrow, and it doesn't notch 60, then it doesn't do anything.
Right, and that's something that I'm going to have to investigate because it's not that, I mean, the 60 hertz can be filtered out with software, and that's fine.
And
but
don't forget that not everyone runs 60 hertz mains.
right. So I mean, there's going to be a need for 50 hertz and 60 hertz filtering, and even it's even possible in some locations to get both 50 and 60 hertz interference as well. I've seen that in some data, but that's going to be something that I'm going to investigate later.
Sounds like a
just-
software filter is a better choice
Well,
if you can do it.
well, right, and I could, but the issue is that the if the 60 hertz mains overloads your input, then you're just going to get clipping, and your filter is going to work. So that's why that I was thinking about, for certain situations, a notch filter could be added just to notch out, even by 20 or 30 dB, which might be enough not
But
to
you can make
overload the
these-
input.
You're going to put these external to the board anyway, right?
Well,
These not going to be on the VLF board. They're going to be external to it, right?
Ideally, you could put them on the receiver, and that'll be fine.
You have limited space, remember. Then you got to have
Well-
four channels of filters, right?
Yeah. Well, I think with 0603 parts, even just passive filters.
Using the big parts, huh? That was a joke.
Well,
I like 0402s.
Well, right. Even something like that, since the leaf board is so big, there's going to be room for extra circuitry.
Hey, be careful when you say it's so big. That's what I thought about the clock module too. When I tried to put all those parts on there, and my CAD guy's saying, where are you gonna put them on the edges? Where do you want to put these? And it looks big because it's like 4x or 8x, but it's really only like that big. So now maybe a little bit bigger. So it's always a challenge. Yeah.
Well, I mean, normally you would put a little bit of filtering in your VLF receiver anyway, and most people won't be able to operate their VLF receiver in areas if you're right next to a power line. You're going to have hundreds of millivolts per meter on the antenna of power line interference, and it's going to overload. It's going to overload the input of the VLF receiver, and also the input of the A to D, and there's nothing you can do. So in those locations, it can't be used. But that's why that I was thinking about adding, just a minimal notch filter on the board, since there's room where it might just be enough where we could get.
Make a suggestion is that you write a specification for the board. Otherwise, you're going to be spinning all around trying to decide what to add on the board. And one guy will want it, another guy won't want it. You'll want it, or you won't want it. And if you have a specification, then you can justify these parts have to go on the board because we need this performance. So if you have to reject 60 hertz, 30 dB, put it in the spec, and then you have to do it.
Okay. Well,
it may help you. I don't know.
Yeah. No. You're right. I think for the first go around, though, we'll avoid the filter altogether.
It's something you could easily add to the input off the board, and then if you want to put it on the board, and you could do something like we did with the RF module. In fact, maybe what you would do is use the same exact header spacing as we used on the RF module, and it's for building a custom filter that you can add, that you can plug in.
Oh, that's true. Yeah, that's right.
Same spacing and the same pin out, and then we can build filters that will work on the RF module or on your module. And it's likely if you're going to build a bandpass, you're going to have the same topology. All you're going to use is different part values. So you can build a PC board, and then you can populate it one way for 60 hertz and one way for 50 hertz, and then another way for that 1.1 megahertz broadcast station that's next door to you.
That's true. Yeah, it's a good idea, and there is enough room. I mean, like if we have even if we could do an active filter or even a passive filter, it's just going to be like a small little, maybe
postage stamp size, right?
Yeah, even smaller maybe. So
yeah, I don't really remember what our RF, what the dimensions is of the RF module. And you can theoretically, you can make the board bigger than the space between the connectors if you want to put the connectors not at the edges and make the board that wide and the connector space like this. You can route around them. So you could even, I mean, there's not really a lot of limitation on the RF module for size because they're on different sides, different edges, near different edges of the board. So you could really make the filter boards pretty darn big and still plug on. And
oh, that's true.
so just in case, I mean, because I figure 60 hertz, you might need some pretty big inductors. So
well, I was thinking something like a twin T notch where we won't have to use inductors. That was pretty effective.
But send an email to Tom and ask him about this because he's already designed filters, optional filters, because we had to make sure that we could fit it on the board. So he took a broadcast band notch filter and designed one up and selected components and everything. And he actually has a layout of the board, the optional filter board that we could make that would be a BCB reject filter that you could plug on. So we wanted to make sure that it was possible to do before we go lay the board out and have the filter all set up and then find out that you can't fit the components on the board. So ask him about it because maybe you can use some of him, and he's a genius when it comes to these filters. So he could certainly be able to help you do it any way you want it.
Okay. Sounds good.
All right. Well, we've gone over like 2.5 hours.
Yeah, I was gonna say, I think I'm ready to say 73 for the night.
It's like 11:30 there, Nathaniel, right?
11:23.
Oh, but it was good.
Yeah, it was a really good meeting tonight. I think, and I felt more energetic than usual, which is good. But we didn't have the student meetings. Like usually Mondays I have like, I don't know, 6 or 8 hours of meetings on Zoom during the day. And by the time I get to like this meeting, I'm like done. So
well, today we were trying to clean out the staging area in the living room of all the stuff because we're trying to empty the house out somewhat to get like floor coverings done and things like that. And it was like 110 degrees out, and we're moving stuff to the storage shed. And of course, we didn't do it smart like at 5 in the morning. We did it at 11 o'clock or something. Oh, it's just the heat
so hot.
Just like wipes you out, and you
yeah.
So, but I can see how 8 hours of Zoom meetings would wipe you out too. That's well, because I got a TangerineSDR presentation in a week from Thursday.
Okay.
And it is for the local club here, and it's the first one live since the pandemic started. He gave me the choice, Zoom or live, and I said no Zoom. I don't want to do a Zoom. I want to see people out there.
That's right. I like it.
So
yeah, I'm giving a talk in South Africa on Saturday morning. At like
hopefully it's a Zoom one, right?
That one is on Zoom, yes. Where I am South Africa. So I've got to get that.
Are you going to be at what's the thing in August? The ham
the QSO today?
Yeah, I think that's
I wasn't planning on it.
Okay.
So no.
Well, John and I are both giving talks there, but
wonderful.
John Ackerman, he's not giving it on Tangerine per se, he's giving it on timing in general.
That's good. Yeah.
And I'm going to talk about the tangerines. So
wonderful.
We can be closer to actually building some before too long. It's just really frustrating.
I know.
Get so close, and I mean, we're already late, but it's like now I got another thing that just stops us dead that I can't get around.
I know. Oof, believe me, I'm.
Yeah, really. We're all waiting for hardware, and it's like, no.
Do what we can do.
By the way, this is my antenna for field day behind me.
I like it.
It's the rocket launcher. We call it a rocket launcher because it's cylindrical tubes, 8 of them, 5 feet high, and about 6-inch diameter with flanges on them. You can't even see how it's put together, but at the guy points, there's joints and 3 tubes in between each one. So
Yeah.
we put that all up in about 2 hours.
Wow.
There were 3 of us. So
that's awesome.
It was fun, another fun field day. So time to go to bed.
All right. Good night, everybody.
73.
73.
73.